A constructor is like the first thing you do when you get a new toy. You open the box, put batteries in, and attach the pieces so it can work. Without this preparation, the toy would just sit there useless. A destructor is the opposite. When you are done playing, you turn the toy off, take the batteries out, and put everything back in the box. In programming, constructors set up the internal data, such as memory, file handles, network connections, and so on, so the object can be used safely, and destructors clean up those resources so nothing is left dangling. If we skipped constructors, objects would start life in a messy, undefined state. If we skipped destructors, the program would leak memory or keep files open forever, just like leaving a faucet running. Constructors come in several flavors, each with a simple, everyday analogy. Default constructor: imagine a plain white t-shirt that needs no size or color choice. In code, it is a constructor that takes no arguments and gives the object a sensible empty state. Parameterized constructor: this is like ordering a pizza with specific toppings. You pass argument size pepperoni olives, and the object is built exactly the way you asked. Copy constructor: think of making a twin of a toy you already have. The program receives an existing object and creates a new one that looks the same, copying all its data. Move constructor: picture handing over a backpack that already has a snack inside to a friend. Instead of copying the snack, you simply give the backpack to the friend and leave yours empty. In code, the move constructor transfers ownership of resources from the source object to the new one, leaving the source in a safe, empty state. These different constructors let the programmer decide how much work to do. When an object appears, just like you decide whether to get a plain toy, a customized one, a duplicate, or a handed-off version. When a class has many member variables, the order in which they are created matters, just like building a sandwich. You must lay down the bottom slice of bread before adding cheese, and you cannot put the lettuce before the bread exists. In C++, the compiler creates members in the order they are declared in the class, regardless of the order you write them in the constructor's initializer list. Using an initializer list lets you set each member directly at the moment of its creation, which is both faster and often required for const or reference members. ClassPerson open brace newline standard string name semicolon comment created first newline int age semicolon comment created second newline public colon newline person open parenthesis const standard string reference n comma int a close parenthesis colon name open parenthesis and close parenthesis comma age open parenthesis a close parenthesis open brace close brace comment correct order newline close brace. If you reverse the list, age open parenthesis a close parenthesis comma name open parenthesis and close parenthesis, the compiler would still initialize name before age because of the declaration order, which can lead to subtle bugs if one member depends on another. The rule is simple: declare members in the order you want them built, and use an initializer list to give them their initial value right away. RAII stands for resource acquisition is initialization. Think of borrowing a library book. When you take the book off the shelf, you have acquired a resource, the right to read it. When you finish, you must return the book, otherwise the library loses a copy. In RAII, the borrowing happens inside a constructor. The object acquires a resource such as memory, file descriptor, lock, etc. And the return happens automatically in the destructor when the object goes out of scope. Because the destructor is guaranteed to run, even if an error occurs, the resource is always cleaned up deterministically. This eliminates leaky bucket bugs and makes code easier to reason about. You just create an object and trust that its lifetime exactly matches the period you need the resource. A classic C++ example is std lock guard of std mutex, which locks a mutex in its constructor and unlocks it in its destructor, ensuring the lock is released no matter how the function exits. When you delete an object through a pointer to a base class, the program must know which destructor to run. If the base class destructor is not declared virtual, only the base part is destroyed, and the derived parts cleanup code never runs, like pulling a toy car apart but leaving the wheels still attached. Declaring the base destructor virtual creates a table of destructors vtable so that the most derived destructor is called first, then each base destructor in turn. This forms a safe inheritance chain. Class animal open brace public colon virtual tilde animal open parentheses close parentheses Open brace std count, less quote animal gone backslash in quote semicolon, close brace semicolon class dog colon public animal, open brace public colon tilde dog open parentheses close parentheses, open brace std count less quote dog gone backslash in quote semicolon, close brace semicolon animal star p equals new dog open parentheses. Close parentheses semicolon delete p semicolon prints quote dog gone quote, then quote animal gone quote. If tilde animal were not virtual, only animal gone would print, and any resources owned by dog would leak. Hence, any class meant to be a base for polymorphic use must have a virtual destructor. Exceptions are like sudden storms that can interrupt the normal flow of a program. If a constructor throws an exception, any members that were already constructed must be destroyed immediately to avoid leaks. The compiler does this automatically. Class widget open brace newline 2 spaces standard fstream file semicolon comment. Opened first newline 2 spaces, standard vector less than int greater than data semicolon comment. Constructed second newline public colon newline 2 spaces widget open parenthesis const char star name close parenthesis colon file open parenthesis name comma standard ios colon in close parenthesis open brace newline 4 spaces. If exclamation mark file close parenthesis throw standard runtime. Error open parenthesis cannot open close parenthesis semicolon newline 4 spaces comment. If we throw here comma file apostrophe s destructor runs automatically newline 2 spaces close brace semicolon. During destruction comma if a destructor itself throws comma the program is in danger because another exception may already be propagating. The safe rule is colon destructors should never let exceptions escape semicolon. They should catch everything internally. This guarantees that stack unwinding never ends in a double exception scenario comma, which would call standard terminate and crash the program. Copy and move semantics dictate how objects are duplicated or transferred. When you copy an object, the copy constructor creates a new instance that owns its own separate resources, like making a photocopy of a worksheet. When you move, the move constructor steals the resources from the source, leaving the source empty, like handing over your lunchbox to a friend and receiving an empty one in return. After a move, the original, now moved from, object must still be safe to destroy. Its destructor should handle the empty state gracefully. This is why move constructors usually set the moved from pointers to null pointer. Unique pointer to int p1 constructed with a new int 42 which owns memory. Unique pointer to int p2 assign the result of move of p1. P1 becomes null pointer, p2 now owns it. When p2 goes out of scope, its destructor deletes the int. p1 apostrophe s destructor does nothing because it holds a null pointer. The interaction of these semantics with destructors ensures that each piece of memory is deleted exactly once, no more, no less. We can view an object's life as a simple state machine. Let the set of states be S equals open brace not created, constructed, initialized, destroyed close brace. A constructor is a transition function C colon not created to constructed that may also perform initialization, moving the object to initialized. A destructor is another transition D colon constructed to destroyed. Determinism. For any object in a given state, there is exactly one next state when a constructor or destructor runs. No backward edges. Once an object reaches destroyed, it never returns to a previous state. Exception edge. If a constructor throws, the system follows an implicit edge from the partially constructed state back to destroyed by automatically invoking destructors for already built members. Mathematically, the lifetime is a path not created arrow C arrow, initialized arrow D arrow destroyed. Understanding this model helps programmers reason about resource ownership, guarantee that each resource is acquired once and released once, and prevents illegal transitions such as using an object after it has entered the destroyed state.